and welcome to today's IPAC Canada webinar, Electrostatic Technology, a New Method for Surface Disinfection. I'm Jerry Hansen, Executive Director of IPAC Canada. Before we begin, we have a few housekeeping announcements. The lines will be muted for the presentation. If you have a question, please put it into the chat box and it will be answered as soon as possible. If there's not enough time to answer all the questions, they'll be answered in a follow-up Q&A document that will be posted with the recording. A reminder that we must have your full name in order to verify your attendance. If you did not use your full name when logging in, please add it to the chat box and we'll ensure that it's included in the attendance roll. If you are in a group setting, someone from that group setting must list all the group participants in the chat box so their attendance can be verified. The webinar will be posted to the webinar page within 3 to 5 business days. We remind you that it is really important for IPAC Canada and the presenter to receive your input and your assessment of today's webinar. Please go to the webinar survey identified on this slide to input your comments after the presentation. The survey link will also be sent to you with an announcement that the recording has been posted. The Certification Board of Infection Control has approved 1 IPU per webinar hour to be used for recertification. A certificate of completion will be available to download at the end of this presentation. You simply download the certificate and then add your name and print it out when required. All participants may download the certificate of completion, whether they need the Civic IPU education units or if they need it for another purpose. We'd like to thank Clorox very much for their sponsorship of this webinar and Dr. Velez. So our presenter today is Dr. Catherine Velez. She's a senior scientist at the Clorox Professional Products Company, where she leads clinical and research studies and education on electrostatic spray technology and EPA-registered manual surface disinfection. She is a member of IPAC, the Association for Healthcare Environment, and SHEA. We'd like to welcome Dr. Katherine Velez, and Dr. Velez, please start your presentation.
Thank you so much, Jerry. It's great to be here today. As Jerry mentioned, I will be talking to you today about electrostatic technology and specifically how you can use it to disinfect surfaces in healthcare settings. So first, we'll cover just some of the basics of infection transmission and disinfection, and then we'll talk about electrostatic technology, including what the technology is, how it can benefit hospitals, and how to choose one if you are interested in using the technology. Finally, we'll cover the clinical evidence behind disinfection and electrostatics and some agency guidelines for healthcare. Before we talk about electrostatics, I just want to start by grounding everyone on some of the basics of infection transmission as well as surface disinfection. Healthcare-associated infections, or HAIs, affect more than 200,000 Canadians each year. This includes both adults and children. These HAIs are linked to about 12,000 deaths per year, and the cost of these infections is also a major burden on healthcare facilities. There are various studies that have estimated the cost per infection, with the average falling at about $11,000 per case. Looking at the cost nationally, C. diff infections alone account for more than $200 million annually. The pathogens that cause these infections are numerous. SARS-CoV-2 is obviously top of mind for everyone right now, but other dangerous pathogens like C. difficile, methicillin-resistant Staph aureus, or MRSA, and vancomycin-resistant Enterococcus, or VRE, have not gone away just because COVID-19 is a focus. These pathogens are still present, and they're still causing infections, which unfortunately only adds to the stress placed on healthcare facilities. We're still learning about SARS-CoV-2, but we do know that this envelope virus causes respiratory illness and can obviously be fatal. C. difficile, also known as C. diff, is a spore-forming bacterium that can cause serious health conditions such as sepsis and permanent colon damage and can also be fatal. Symptoms of a C. diff infection typically include diarrhea, nausea, and stomach pain that can be caused by colon inflammation. C. diff infections are still top of mind for healthcare facilities because of the difficulty in controlling the spread of this pathogen, and because we unfortunately still don't understand how to detect and treat it effectively. There are some promising new treatments in development, but so far these treatments work only in some individuals. Mrsa and Vre are both antibiotic-resistant pathogens that can cause infections. Mrsa can lead to sepsis and can also be fatal. And from a microbiology standpoint, all of these pathogens can survive and be transmitted via environmental surfaces. So knowing what's at stake for acute care facilities financially and for patients from a healthcare standpoint, hospitals have increased infection prevention measures to help combat the healthcare-associated infections associated with these pathogens. Research into how infections are transmitted is ongoing, but the current understanding is that pathogens can transmit in multiple ways. This could include physical skin contact, contact with bodily fluids, or through contact with the environment. Patients, visitors, and staff who touch contaminated environmental surfaces can infect themselves and others. So eliminating the environment as a source of infection by disinfecting surfaces can allow facilities to turn their attention to other infection prevention measures to reduce HAI rates. Research studies have shown that pathogens can survive on surfaces anywhere from several days to several months, depending on the pathogen and the environmental conditions. Studies on healthcare workers' hands showed the acquisition of VRE and Mrsa on gloved hands after contacting colonized surfaces near patients, including bed rails and bedside tables, without any direct patient contact. Because colonized patients are often unrecognized and therefore not placed in isolation, environmental surfaces can serve as a source of colonization for healthcare worker hands, which can then transmit pathogens to other surfaces and other patients. Surfaces outside patient rooms can also play a role in transmission. Several studies have found substantial bioburden on other healthcare surfaces, such as emergency vehicles, operating rooms, mobile equipment, and even floors. Facility-to-facility transfer can also happen if a patient is transferred, but the receiving facility isn't notified. C. diff is particularly problematic because it can live on surfaces for months at a time. It can also become airborne, for example, when a C. diff patient or an asymptomatic carrier flushes a toilet. Studies have actually measured how far C. diff spores can spread when this happens, and the results suggest that this is one way C. diff can spread to other surfaces. Hand hygiene is a major focus for acute care facilities because it is now known that C. diff can easily be spread from patient to patient via healthcare worker hands. The Provincial Infectious Diseases Advisory Committee, or PIDAC, recommends using environmental cleaning to disrupt transmission. They recognize that transmission can happen either directly via direct contact with the environment or indirectly via spreading from healthcare worker hands or gloves back to surfaces or patients. So now that we understand transmission and how it can be disrupted, let's take a look at some of the solutions that you can use to treat environmental surfaces. Today we're focusing on disinfectants on the right, which are regulated by the Public Health Agency of Canada. Disinfectants can be approved for use in healthcare if they include required claims against Staph aureus and Pseudomonas. Typical organism kill for disinfectants is between 4 and 6 logs, depending on the test method used to get the claim. Hospital disinfectants will have a drug identification number assigned by Health Canada that signals its approval for use in Canadian healthcare settings. Sanitizers in the middle are also regulated, but they currently only have claims for vegetative bacteria, so they can't be used for spore-forming bacteria like C. difficile or for viruses like SARS-CoV-2. Many sanitizers are used to treat food contact surfaces and soft surfaces in particular, although disinfectants can also carry these types of claims. Cleaning products, on the left, do not carry any efficacy claims. Unlike disinfectants and sanitizers, cleaning products do not require efficacy testing or data submission in order to be produced and sold. So that's a little bit about how disinfectants are regulated. Now I want to focus briefly on how disinfectants actually work when applied to microorganisms on a surface. Oxidative chemistries like bleach, which is the active ingredient most commonly found in formulas approved for use against C. difficile, for example, work by deactivating proteins and cell structural components, including the cell wall. Cells are quickly and effectively destroyed by oxidative chemistries, so they don't have a chance to develop any sort of resistance to these types of products. Because bleach is a strong oxidizer, disinfectants containing bleach have to be formulated in such a way that they destroy the microorganisms on the surfaces they're being applied to without harming the surfaces themselves. It can be challenging to develop a disinfectant that kills microorganisms effectively, doesn't harm surfaces, and has a pleasant odor for both the people using the disinfectants and the people occupying the spaces that are disinfected. The other main family of disinfectants you will encounter are quaternary ammonium-based disinfectants, or quats. Quats are not approved for use against C. difficile, but they may be used as a first step to clean and disinfect a room prior to applying a sporicide. Quats are greasy molecules that insert themselves into cell membranes, poking holes in the cells and allowing cell contents to leak out, eventually leading to cell death. Quats are typically slower acting than oxidative chemistries like bleach and hydrogen peroxide. Some quat products also contain alcohol, which can help with protein denaturing and allow easier access for the quat into the cell membrane. Disinfectants also differ in terms of the efficacy they can deliver. This is because different types of pathogens are easier to kill than others. Envelope viruses like SARS-CoV-2 are the easiest to kill on surfaces. These pathogens can be killed by quats, hydrogen peroxide, and bleach-based disinfectants. Vegetative bacteria like Mrsa, fungi, and non-envelope viruses are harder to kill, but can similarly be deactivated by all of the major disinfectant types available. Mycobacteria like tuberculosis or TB are harder to kill and can be inactivated by some quat-based products, but not all. Hydrogen peroxide and bleach are generally better for inactivating mycobacteria. Spores, like C. diff, are the hardest to kill and can only be deactivated fully by bleach-based disinfectants or disinfectants that have both hydrogen peroxide and peracetic acid. You can get some level of disinfection on C. diff with hydrogen peroxide products, but the kill will be lower, and these products are not currently Health Canada approved for use against C. diff. Health Canada approved disinfectants are available in multiple forms, such as wipes, trigger sprays, and dilutable solutions that can be used with a mop and bucket to disinfect large areas like floors. Disinfecting manually is a challenge, though. Even with well-trained staff, it's difficult to disinfect every surface every time. This is in part due to pressure from the facility to turn rooms over quickly so that they're available for the next patient. One study looked at the impact of this on disinfection and found that only about half of the surfaces they tested in hospital rooms were effectively disinfected. Because of this, we need new methods to apply disinfectants to surfaces. Electrostatic technology is one such method that hospitals can use to apply disinfectants to surfaces faster and more evenly than manual disinfection methods. Electrostatic technology is not a new technology. It's actually well established in industries such as agriculture, and it's used for other applications like automotive painting, spray tanning, and even inkjet printing. The reason this technology works so well for these applications is that it allows for even application of a liquid to all surfaces of a complex object while minimizing liquid waste. This technology was recently introduced into the surface disinfection industry, and it has the same benefits for disinfection. Electrostatic technology is a new way to apply the disinfectants that you're already familiar with. Instead of applying disinfectant with a trigger or a pump sprayer, electrostatics takes advantage of technology that charges droplets and delivers them directly to target surfaces. When using an electrostatic sprayer, you can apply disinfectants much more quickly and evenly to surfaces than you would be able to with traditional manual disinfection methods. This can help facilities turn rooms over more quickly if they use electrostatics in place of manual disinfectants, or it can help give facilities extra assurance that spaces are adequately disinfected if electrostatics is used as an adjunct to manual disinfection. So here's how electrostatic works. Focusing in on the nozzle, which is the key part of the system, droplets that leave the nozzle are charged as they exit the sprayer. Those droplets are also broken up into smaller droplets at the same time that they're being charged. This results in evenly sized droplets that repel one another and actively seek out target surfaces like small missiles. Once the droplets reach their target, the charge dissipates and the liquid remains on the surface. The result is an even, uniform coating of disinfectant that can wrap around even complex surfaces like a wheelchair. This is an example of how electrostatic coverage differs from a trigger spray or a mister using a light bulb as the sprayed object. In this example, the light bulb was sprayed only from one side. The sprayer was not moved around the object. As you can see, the trigger spray deposits large droplets on the surface that don't wrap around the object. This is why trigger sprays are typically used along with microfiber cloths that can help distribute disinfectant or remove any liquid pooling that might result. Misters deposit fine droplets evenly onto the surface, but because the droplets are not charged, they leave more than half the surface uncovered. Electrostatic sprayers, on the other hand, are able to coat the entire object evenly. In addition to coverage, electrostatic technology differs from foggers and misters and from trigger and pump sprayers in other key ways. Foggers and misters emit very small droplets. The room vents have to be sealed off prior to application, and typically a long re-entry time will be required before bystanders can re-enter the room. Foggers and misters also passively deposit uncharged disinfectant onto surfaces, which means surfaces will be evenly coated, but not all surfaces will be covered. Trigger and pump sprayers also emit uncharged disinfectant droplets, but the droplets are much larger. Because these larger droplets deposit unevenly on surfaces, trigger sprays typically require a wipe step to distribute the disinfectant or to help surfaces dry after the contact time has been reached. However, vents do not need to be sealed when using trigger sprays, and there are no re-entry times for bystanders. Electrostatic technology actively deposits charged disinfectant onto surfaces. The droplet size is large enough that vents do not need to be sealed, and there's generally no or very low re-entry times for bystanders when using this technology. Personal protective equipment or PPE requirements vary based on the disinfectant that's being applied through the system. So now that we know how electrostatic spraying works, we can start to think about how to best use this technology in healthcare facilities. Electrostatic technology can be used anywhere that you use manual disinfectants today, including patient rooms. It can be used either as a substitute for or as an adjunct to manual disinfection in these areas. Electrostatics is also excellent for covering large areas quickly, such as waiting or exam rooms. Moreover, electrostatics can be used to quickly and evenly disinfect complex objects that are hard to disinfect, such as wheelchairs, workstations on wheels, or other portable equipment. The reason electrostatics works so well for these applications is that it can typically cover up to 9,000 square feet of surfaces in just 30 minutes, which is the equivalent of about 28 average-sized patient rooms. If you're considering using electrostatic technology, there are a few things you should consider when evaluating a sprayer. The first consideration is device design. This is crucial to the electrostatic performance of the device. You should also consider the disinfectants that are paired with the device. If you're using this to disinfect surfaces contaminated with C. difficile, you want to use a disinfectant that is Health Canada approved to kill C. difficile spores and also approved for use with electrostatics. It's also important to consider whether the disinfectant has demonstrated compatibility with common healthcare surfaces. And finally, safety is crucial for any device your staff will use. It's important that the manufacturer provides you with PPE recommendations for the operator. The device should also have appropriate certifications with trusted organizations like UL or Intertech.
Catherine, it's Jerry. I have a question.
Absolutely.
One of our attendees asked, should a respirator be used by the user of the electrostatic since the disinfectant is becoming aerosized?
That's an excellent question. So that depends completely on the chemistry that's being used. So some chemistries may require a respirator, others may not, and the only way that you know is by doing a risk assessment to determine how much of that chemistry is going to be in the air while you're spraying, and will any of it stay in the air after you stop spraying. So using those two pieces of data, you can figure out, okay, do I need PPE if I'm operating the device? And then once I stop spraying, do I need to wait any amount of time before a person re-enters the room? So the answer is it really depends. And we'll talk a little bit more about why that is in the coming slides, but it's a mixture of both the device itself, how it's designed, and the chemistries that are being used through the system. Okay. So the two basic types of electrostatic devices that exist today are AC powered, that is devices that plug into an outlet, and battery powered. The type of power that a device uses is important because it impacts both system performance and operator experience and safety, like we were just talking about. So electrostatics can be used with different types of disinfectants, including ready-to-use or dilutable solutions. Dilutable products can be less expensive than ready-to-use products, but they introduce extra time and labor into the application process. They increase the potential for human error and pose an increased risk in safety if chemicals are mixed improperly. The disinfectants that are specifically designed for electrostatics are best because they contain minimal ingredients and no fragrances. Formulas with added fragrances may be suitable for use through a trigger sprayer, but may cause excessive odor or irritation if applied through an electrostatic sprayer. So AC-powered or corded electrostatics provide two major benefits over battery power. AC power provides consistent, reliable droplet charge, meaning that product performance will also be consistent and reliable. It also allows for inclusion of an air compressor or a high-powered fan in the system. What this does is it helps divide disinfectant into evenly sized droplets that can hold a charge and reach target surfaces successfully. Battery power can allow for more mobility, and it eliminates the need for cord management, but at the cost of system performance. This is because the rechargeable lithium-ion battery technology that's used in these types of sprayers today is not yet advanced enough to provide true electrostatic performance. The power in these batteries can fluctuate and diminish during spraying, resulting in less even surface coverage, reduced wraparound object, and inconsistent droplet charge, which can cause liquid to fall to the floor before it reaches the intended target. Batteries also require replacement and constant management to ensure that they're charged and functioning properly. Corded systems also provide an important safety and operator experience element, which is system grounding. In order to charge droplets, electricity is needed, which requires a ground. If the sprayer is plugged into an outlet, the outlet provides the connection to the ground. However, battery-powered devices have to either use the operator as a ground or include a separate foot attachment that the operator wears to connect the device to the earth as a ground. These options are not ideal, and both result in a significant reduction in device performance. The difference between corded and battery-powered electrostatics can be seen best in a side-by-side comparison of performance. In this example, metal trash cans were sprayed with a fluorescent dye through a corded sprayer and a battery-powered sprayer, with the nozzle held 4 feet away from the object. Looking at each side of the trash can, you can see it's fully covered on all sides when a corded sprayer is used, but only the front and part of the side is covered when using a battery-powered system. This demonstrates that battery-powered sprayers are essentially no different than trigger sprayers in terms of object coverage and wrap. Electrostatic spraying is a process that involves the sprayer, the disinfectant, and the operator. A disinfectant product's safety and effectiveness may change based on how you apply it. For this reason, it's important to assess the electrostatic technology together with paired disinfectants for both operator and bystander safety. Companies that manufacture both electrostatic technology and disinfectants are best positioned to provide this type of assessment because they can test them as a paired system. The disinfectants used with electrostatics should be Health Canada approved for that use. Because monographs are not publicly available on the Health Canada website, if the product is also sold in the U.S., you can search for the U.S. EPA-approved master label, which is publicly available on the EPA website. If the disinfectant master label does not include disinfection directions for electrostatic spraying, then that means the EPA has not evaluated the product's safety and efficacy for that application method. Manufacturers should also be able to demonstrate how well their sprayer delivers disinfectants and sanitizers to all sides of complex objects, which is a key indicator of sprayer performance. Surface compatibility is also important, since compatibility of a disinfectant when applied through an electrostatic sprayer can differ from what you would get if you applied the same disinfectant via a wipe or a trigger spray. Generally, compatibility will be superior when an electrostatic sprayer is used because less liquid is applied to surfaces and the coating is more even than a wipe or trigger spray application. The EPA master label is a good starting point when considering compatibility because it includes a list of approved use sites and surfaces. So, as we talked about, specific disinfectants should be assessed with specific sprayers to determine PPE requirements for the operator and to make sure there is no reentry time for bystanders. While disinfectants may be safe to use through electrostatic systems, a risk assessment is crucial because the PPE requirements for applying a product through a trigger sprayer may be different than the PPE requirements to apply that same product through an electrostatic sprayer. Without a safety assessment, the user doesn't know if the device and the chemical are safe when used together. The manufacturer should be able to provide you with an SDS for each disinfectant recommended for use with the sprayer that contains information on the appropriate PPE recommended for use with electrostatics. The sprayer itself should be tested and certified by a nationally recognized testing lab such as Intertech or Underwriters Laboratories. Most established sprayers have this certification, but as new sprayers pop up on the market in the wake of the pandemic, it is possible that some of these newer devices may not have all the necessary certifications. Manufacturers should be able to provide proof of these certifications, including a description of what they cover. Typically, sprayers should be tested against standards for motor-operated machinery and cover safety in terms of fire, electrical shock, and overall safety to people and property. I mentioned that you can consult the master label for a list of approved use sites and surfaces. However, some disinfectant manufacturers have conducted additional compatibility testing with surfaces commonly found in healthcare to help facilities understand how can you balance the risk of equipment damage with the need to disinfect and limit infection transmission. Compatibility testing should be done separately for each method of application because the compatibility of a disinfectant when applied via electrostatics may be different than the compatibility when that same disinfectant is applied via wipe or trigger spray. Often, as I mentioned, the compatibility with electrostatics will be superior because disinfectant can be applied more evenly to surfaces. Understanding disinfectant compatibility can help you maintain surfaces and equipment in your facility long term. Odor and residue profile are also important considerations because they affect both the applicator experience as well as the patient experience. Patient experience is important because it can affect facility scores on surveys used to assess hospitals on quality of care. Visible residue in particular can cause patients to think facilities are not clean when in fact they have been thoroughly disinfected. One way some facilities mitigate this is to have a residue removal day periodically, say once a week, where surfaces are wiped to remove disinfectant residue and keep surfaces looking polished. Product odor can be a positive indicator for patients that spaces have been cleaned, but it shouldn't be so strong that it negatively impacts the patient experience. The final consideration when choosing a disinfectant is contact time. Shorter contact times lead to better compliance on the part of the applicator. Ideally, Aerosized will have a Acetif contact time of 5 minutes or less. Products with higher contact times often need to be reapplied, leaving more room for human error. Contact times against other easier-to-kill pathogens should be even shorter. A contact time of 2 minutes or less is generally ideal. Compliance is important because it helps facilities make sure that surfaces are adequately disinfected. When using sporicides through electrostatic technology, applicators should be trained to make sure they understand how to apply the product to achieve the required contact time.
Catherine, there's a question from Helen. Is pre-cleaning of organic material required?
For C. diff, yes, and I believe that is the same in Canada, so I have to qualify the statement by saying I am an American and I know our laws better. But the US EPA and I believe also Health Canada will require that you pre-clean surfaces when C. diff is present. So that's specific to C. diff. There are some disinfectants that also require pre-cleaning for other pathogens. And the way you'll know is, again, if you can't get a hold of the monograph from Canada, if it's sold in the US, you can look up the EPA master label, and it will tell you on there if it requires an additional step. Usually, another way you can tell is if the product is called a cleaner disinfectant. That means that it has both a surfactant, so that's the cleaner, as well as disinfectant in it. So in that case, you don't need a pre-cleaning step because when you apply the product, it can both break up the dirt with the cleaner as well as disinfect the surface at the same time. There are many products, though, that are purely disinfectants that require you to clean surfaces first. However, with any disinfectant, you always have to remove visible soil. So the cleaner disinfectants are taking away anything you can't see that's still there on the surface. But any blood, bodily fluids, that always has to be removed before you apply any disinfectant. So finally, operator experience is just as important as safety and disinfectant efficacy. Devices should be ergonomically designed so that operators can use them comfortably throughout the course of their shift. Make sure that the manufacturer can also provide training for your personnel. This includes providing the SDS for each disinfectant recommended for use through the sprayer with information on the appropriate PPE to wear when using each product through electrostatics. So now that we've discussed electrostatic technology, I'll walk you through some of the clinical evidence and guidelines supporting disinfection generally, as well as disinfection with electrostatic technology. So several studies have highlighted the ability of pathogens to transfer throughout the healthcare facility using portable equipment like workstations on wheels and shared equipment like wheelchairs. Since C. diff is harder to kill, it can linger on equipment. Wheelchairs in particular have been found to be contaminated with all manner of bacteria. This is because wheelchairs are not disinfected as regularly as patient rooms and because the complex surfaces on a wheelchair can be difficult to clean and disinfect. To prevent transmission, Health Canada recommends dedicating non-critical equipment to a single patient. They also recommend both terminal and routine cleaning and disinfection of patient care equipment to disrupt the spread of pathogens from room to room. Disinfection has to be documented, supervised, and monitored to make sure it's happening as expected. Finally, disinfection will be easier if you use surfaces in your facility that can be easily cleaned and that can stand up well to repeated disinfection. For environmental disinfection of C. diff, IPAC recommends using sporicidal disinfectants to treat surfaces in C. diff patient rooms. Because C. diff can spread from room to room, and because asymptomatic patients are not always identified, many facilities choose to use sporicides on all patient discharges, whether the patient was confirmed to have C. diff or not. Either way, the sporicide used for patient room disinfection should be Health Canada approved. Bathrooms should be a particular focus when C. diff is suspected, including bathrooms in ambulatory areas where C. diff patients are present. Extending bleach use hospital-wide has been shown in multiple studies to be an effective way to reduce CDI rates and mortality, to decrease time between CDI cases, and also generally improve patient and staff experience. These infection reductions also translated to a reduction in costs for the healthcare facilities where these studies were conducted. Knowing the limitations of manual cleaning, facilities need multiple measures to help enhance environmental disinfection. One option is to use sporicides in all patient rooms, not just C. diff rooms, to make sure that C. diff may have spread from room to room or C. diff shed by asymptomatic carriers is killed on all surfaces. This can help prevent spread to the next patient. Another option is to use new technologies to enhance disinfection, such as electrostatic sprayers. The sporicidal disinfectants paired with electrostatics have been shown to be effective in reducing C. diff contamination in the hospital environment. In a recent study, researchers found statistically significant reductions in C. diff contamination on portable equipment, wheelchairs, and waiting room surfaces when a sporicide was applied via electrostatics without any wiping or pre-cleaning. They also found that electrostatic application of the sporicide was just as effective as manual wiping, but could be applied 4 times faster.
Catherine, there's a question about spraying of disinfections and occupational health advising to use squirt tops instead. As the disinfectant is sprayed with electrostatic sprayers, would this be a concern?
Yeah, so definitely consult your guidelines and check which areas of the hospital you might be able to use sprays in versus not. I can tell you that in the U.S. there's no hard guideline. It's just kind of preference and where you feel comfortable. In general, electrostatic sprayers, we do not recommend that you use them in any room where a patient is present. So typically the concern is, would a patient breathe it in? Would someone near a spray breathe it in? Or are you aerosolizing pathogens? We've heard those concerns. So electrostatic spraying is meant to be used with only the operator present. So as long as the operator is wearing the appropriate PPE, then that is not a concern for that situation. So it really depends on where you want to use it in the facility.
Thanks, Catherine. Another question. One of your pictures shows that the user is not wearing a mask, and this brings us back to a previous question about whether a respirator is required by the user. Can you comment on that?
Yes, again, so apologies if that wasn't a clear response. It does depend on the chemistry that you're spraying through. So for the chemistries that we offer, some of them do not require a respirator, others do. And again, the only way that you know that is by doing a risk assessment. So actually having people spray in a room with sensors to figure out how much chemistry is in the air when I'm spraying, and is the level high enough that I would need to wear a respirator. That's how you determine that. So really, you need to work with the manufacturer. They should be providing you with that SDS that has specific PPE recommendations for each chemistry that you want to put through the sprayer. So it does vary. Unfortunately, there's no hard and fast rule. Okay.
Thanks, Catherine.
No problem. Okay, so one more study that I wanted to run through with you. In this study, a sporicide was applied to floors using electrostatic technology as part of a two-part intervention on a COVID-19 ward and an ICU. In this study, researchers tested high-touch surfaces, floors, and stocks in patient rooms for SARS-CoV-2, and they did the same test outside patient rooms at nurse stations and on floors, mobile equipment, and shoes. Before the intervention, 36% of surfaces were found to be contaminated with SARS-CoV-2. Although bleach wipes were used in the patient rooms and hydrogen peroxide disinfectants were used outside patient rooms, floors were only cleaned with a detergent. So for the first intervention, floors were instead cleaned with a clot disinfectant. This reduced the sites positive for SARS-CoV-2 down to 20%. For the second intervention, floors were cleaned with both a clot disinfectant as well as a sporicidal disinfectant applied via electrostatic technology. With the addition of the sporicide applied through electrostatics, only 3% of surfaces were found to be contaminated with SARS-CoV-2. So HAIs continue to be an issue for healthcare and require multiple modes of intervention. Hopefully, I've convinced you that novel solutions like electrostatic technology can help you in your facility to eliminate the environment as a source of infection. Thank you, everyone, for listening today, and I'll be happy to take any other questions.
Thank you so much, Catherine. Really interesting presentation with the options available. Two questions that I will try to combine into one. One is concerned that the product can be used in a dental setting. You have said that patients or residents should not be in the room when this is being used. But there is a question around wiping off the product. In the dental setting or anywhere, how many minutes before it has to be wiped off? And will it erode the quality of will some products damage plastic or metal surfaces?
Yeah, that's an excellent question. So that is going to depend on the chemistry that you're using. Like I mentioned earlier, in general, with electrostatics, you're getting that nice fine, even coating. So whichever disinfectant you use, generally the compatibility is going to be better than what you would see with like a trigger spray or even wipes. But if you have a sensitive materials like you'd find in a dental setting, you might be better off using a clot, for example, than a sporicide. And that might be overkill. You may not need bleach in a dental setting. But if it is required, then you want to choose one that has minimal ingredients, because the more ingredients it has in it, the more potential it has to harm surfaces. And then, like we talked about earlier, make sure the manufacturer has done some testing. So you can start with that EPA master label or the monograph if it's available. That will have a list of approved use sites and surfaces. So that will tell you if you can use it on plastics and metals and things like that, or if you can't. But additionally, it's always good if the manufacturer has done their own testing so that they can show you, when I spray it through my sprayer, this is what happens, and we expect this kind of compatibility long term. So usually, these kinds of surfaces are okay to be sprayed many, many times before you would notice any issues. You probably don't have to wipe residue every time, but again, it really depends on the disinfectant that you're using and what ingredients are in it, in addition to just the active ingredients.
Thank you, Catherine. A question from Gilles. What is the application for gymnasiums?
Oh, that's a great question. Yeah, so this can absolutely be used outside of healthcare, and there are many people that do just that. So there are schools that spray down gyms, locker rooms, any kind of big open area. This is really great for that because, as I mentioned, you can cover up to 9,000 square feet in just 30 minutes. So really anywhere that you disinfect today, you can take this system.
Thank you, Catherine. Were there any other questions of Catherine? I see that we have multiple attendees typing, so we'll just wait for a moment. Steph asks, would spraying on equipment that is connected to outlets and have electronic components be harmful to the equipment? And will it have a negative effect with the disinfection process of the positive charge?
Yeah, that's a good question. So electrostatic spraying, it's generating a temporary charge on the particles. It dissipates immediately once it hits the surface. So we have tested on various types of electronics and equipment. Our chemistries are approved for use on electronics. There have been no issues. We even did a very controlled, safe experiment where we sprayed an outlet in a test setting, and it didn't even trip an outlet. So it is actually very safe to use around these items. If there is anything that you're concerned about, you can always just not spray it. It can be present in the room, and you just spray around it. So some facilities will choose to do that if there's a particular piece of equipment that they don't feel comfortable spraying, but we have not heard of any issues with that.
From Brian, how can we determine sufficient coverage is achieved via the electrostatic application?
Yeah, so that's a good question. When you're spraying the actual disinfectant, the only way you can really tell is by spot checking to see if all your surfaces are getting wet. However, if you want to get a sense of, for training, how am I going to train people to spray surfaces properly, we offer a fluorescent dye that you can put through the system. It's just essentially a laundry brightener in water. And you can spray that on surfaces and then see with a black light, am I covering all the surfaces that I want to? So that can help you just for training purposes, just to get a sense of how long do I have to spray, kind of what's the motion that I need to spray. And then once people are comfortable with it, they can take that with the real disinfectant into the rest of the hospital.
And is the dye available through local representatives or a national?
So you can definitely get it through your sales rep. I don't believe it's available for sale separately, but they should be able to get some for you for training purposes.
Frank asks, what is the maximum distance you can be to a surface to get coverage?
That's a good question, and that depends on the device. Usually it's going to be between 2 and 4 feet away. So you're actually a lot further away than you would be with like a trigger spray, where usually you're very close to the surface, maybe like 6 inches away or less. These sprayers are a lot more powerful, so you don't need to be very close to the surface to get really excellent coverage. So generally 2 to 4 feet.
Thank you. Are there other questions for Dr. Velez? People typing? We'll just wait for a moment. Okay, so Frank asked if there's lingering bacteria in the air, can the spray disinfect the air itself?
That is a great question and something that we're wondering ourselves. It's not something that there is currently a test method to get that approval. It may, and there is more to come on that once we find out. But yes, we have been asked that question, and hopefully there will be a method in the future to actually test against that, and then we can get it approved and add it to the label.
Are there any additional questions for Dr. Velez? Where we go, it appeared. What is the PPE required for the disinfectant cleaner?
Oh, okay, great. So it sounds like you're familiar with our product. So we have 3 different disinfectants that you can use through our system. So the one you're asking about, I'm assuming, is our clot-based disinfectant. And for that product, you need a N95, just a regular N95, no special cartridges. And for all of our products, we generally recommend that you wear safety glasses. You don't have to. It's not a requirement, but we recommend it more just for the sprayer itself can be pretty powerful. So just in case it doesn't hurt, have eye protection. And then if you want to, you can wear gloves. Again, that's optional. For our sporicidal, you actually do not need any sort of respiratory protection. And then we also have a lower level bleach disinfectant that's better for food safe surfaces. And that one also does not require any sort of respirator or respiratory protection.
Thank you, Dr. Velez. Are there any other questions on the practice or the use of the electrostatic